Hello! Did you miss me? I thought so. The purpose of today's lesson is that you will be able to add rational numbers. And specifically in today's lesson, the rational numbers we're going to be adding are integers, because remember, integers are rational because they can be written as a fraction. So think about the integer game we played today. What happened today if you had a positive number in your hand and you drew a positive number? The value of your hand increased. If you had a positive 2 in your hand and you drew another positive 2, the sum of your hand would be 4. So the value of your hand increased. What happened to your hand if you had a negative number in your hand and then you drew a negative number? The value of your hand decreased. For instance, if you had negative 1 in your hand and you drew a negative 2, the sum of your hand would be negative 3. If you use your number line right down here, here's the sum of your hand at first, a negative 1. You drew a negative 2, so we count down 2, 1, 2. So the sum of our hand is negative 3. Our hand decreased in value because we're further away from 0 on the number line. What happened when you had a positive number in your hand and you drew a negative number? The value of your hand decreased. For example, if you had a positive 4 in your hand, but you drew a negative 3, the sum of your hand would be 1, because you'd start at 4, count down 3, 1, 2, 3, and the sum of your hand would be 1. So the value of your hand went from 4 to 1. It decreased. And finally, what happened to the value of your hand when you had a negative number and drew a positive number? The value of your hand increased. For example, if you had negative 3 in your hand and you drew a positive 5, the sum would be a positive 2, because you'd start at negative 3, count up 5, 1, 2, 3, 4, 5, and we'd end up on 2. The value of our hand increased. We started with negative 3 and ended up with 2. Positive is greater than negative. Now let's think about these situations using the number line or using money, like we did in the activities in class. What would be the pattern if both numbers were positive? For example, 5 plus 4. Remember, when using the number line, we always start on 0. So we're going to count up 5. 1, 2, 3, 4, 5. And then a positive 4, we'd count up 4 more. 1, 2, 3, 4. We end up on 9. Or using the money situation, we used green money to represent positive numbers. So 5 positives plus 4 positives, we would have a total of 9 positive dollars. But what was the pattern when using both positive numbers? The pattern was the numbers were added together and your answer was positive. We were only working with positive numbers, so our answer would have to be positive. Let's try another one. What if both numbers were negative? For example, negative 6 and negative 4. Let's start at 0 on the number line, count down 6, 1, 2, 3, 4, 5, 6, and then we have 4 more negatives, so we're going to count down 4 more, 1, 2, 3, 4. We end up on negative 10. Or if we're talking about the money situation, remember we used red money to represent debt or owing money. So we have 6 negatives, 6 red dollars, and 4 more negatives, and altogether we have 10 negative dollars, or debt or owing $10 to someone. So what was the pattern in this example? The pattern was that the numbers were added together and your answer was negative. It was negative this time because we only had negative numbers we were working with in this problem, negative 6 and negative 4. What if one number was positive and one number was negative? For example, negative 10 plus 15. Some of you might want to use the commutative property to rewrite this problem as 15 plus negative 10. remember with the commutative property, you can add numbers in any order and still get the same answer with addition. So we should have the same answer for both of these problems. Using the number line, we would count down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then from there, we're going to count up 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We ended up on 5. Now that seemed pretty tedious, so that's why we're going to come up with a pattern for these type of problems, so that we don't need to use the number line every single time. If using the negative and positive money situations, we would have 10 red dollars for negative 10 and 15 green dollars for 15 positives. And remember, negative 1 represents our negative dollars and a positive 1 represents our positive dollars. And we talked in class about these being zero pair, or when you add opposites, you always get 0, additive inverse. So all these cancel out. And you end up with 5 positive dollars. Let's come up with a pattern for this situation so that we don't have to show all this work every time. So remember in class, we talked about negative numbers are the same thing as take away because we're going towards those negatives on the number line. We're taking those numbers away. Or if we used a commutative property to set this up, adding a negative is the same thing as taking away 10. So we get 5. So our pattern would be the numbers were subtracted and your answer was positive because there were more positives. We had 15 positives and 10 negatives. And that we showed that with the money. We had more positives than we did negatives, so our answer would have to be positive. And we subtracted because negative is the same thing as taking away. Let's come up with a different situation where one number is positive and one number is negative. For example, negative 9 plus 4. On the number line, we would count down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. From there, we're going to count up 4. 1, 2, 3, 4. We end up on negative 5. Or if using the money situation, we would have 9 red dollars representing we owe $9. And we have $4. So we are able to pay back those $4. They cancel out, 0 pair, but we still owe $5, or we're still in debt $5. Red money represents a negative integer. Let's come up with a pattern for this situation. It might be easier for some of you to use the commutative property to rewrite this problem as 4 plus negative 9. Because remember with the commutative property, the numbers can commute, travel, change location, and when we add them together, we will still get the same answer. So the pattern here was that we subtracted the numbers because I see a negative, and negative means to take away. So 9 minus 4 is 5. However, our answer was negative because we had more negative numbers than we did positive. So what was the difference between part C, negative 10 plus 15, and part D, negative 9 plus 4? Both of them asked for us to provide an example where we had a positive and a negative number. The difference is we subtracted for both of them. So 15 minus 10 is 5. But here we had 15 positives and 10 negatives. Our answer is positive because we had more positives than negatives. But in this example, we had 9 negatives and 4 positives. We still subtract the two numbers because of that negative symbol, meaning take away. But here our answer was negative because we had more negative numbers than we did positive. That's the difference between those two. Here's a summary of the patterns we just discussed. If the signs are alike, you add. Then ask yourself, are there more positives or more negatives? Take the sign of whatever you have more of. For example, in this problem, I see that the signs are alike, the signs being negatives. Because they are alike, I'm going to add. 8 plus 4 is 12, and our answer has to be negative because I only have negative numbers. I have 8 negatives and 4 negatives. If the signs are different, you're going to find the difference. And remember in math, finding the difference means to subtract. I can use the commutative property to rewrite this problem. 13 plus negative 11. The negative 11 just commuted or traveled behind the 13. We should still get the same answer. And then in class we talked about adding a negative is the same thing as taking away that number. So 13 minus 11 is 2. Using this rule though, the signs are different. And some of you might be thinking, but Mrs. Snodgrass, that's an addition symbol, not a positive. I could rewrite this as negative 11 plus a positive 13. You just don't see that positive symbol in front of our positive numbers. So our signs are different, so I find the difference. 13 minus 11 is 2, and I have more positives than I do negatives. I have 13 positives, 11 negatives. My positives outweigh the negatives. Remember with opposites, the sum of a number and its opposite is always 0, additive inverse. So 7 plus negative 7 would equal 0. Go ahead and pause the video now and try the next section by yourself using these patterns. Let's see how you did. For the first one, the signs were different, so you should have found the difference, and you had more negatives than positives, so negative 13. The next one, the signs are alike, so you add, and you have all negatives, so you get negative 19. The signs are different, so you find a difference, or they're opposites. Opposites always equal 0, additive inverse. For this one, you don't see the positive in front of the 14, but the signs are different, so you find the difference, and you have more positives than you do negatives. Here, the signs are alike. We have both negatives. So when they're alike, you add, and because you have all negatives, it'd be a negative 24. Over here to the right, we work from left to right in order of operations. Remember order of operations, grouping symbols, exponents, multiplication and division from left to right, addition and subtraction from left to right. So we need to work from left to right since we have all addition. The signs are different, so I found the difference and I had more positives, which is 9. You're not going to see that positive in front of the 9, but the signs are alike, so you add. You have all positives, so positive 22. And it's a positive 22, so the signs are different, so you find the difference, and you have more positives, so a positive 17. The signs are alike, so you add, and they're all negatives, so negative 10. Once again, the signs are alike, so you add, and you have all negatives, so negative 15. And then finally, the signs are different, so you find the difference, negative 1, and we add negative because we have more negatives than positives. And then the signs are alike, so we added, and we have both negatives, so it would be a negative 2. Hopefully you were able to do these problems without using the number line or money. Using the patterns allows you to compute these problems without using visuals. If you have any questions, please come to class and I can help you. See you tomorrow.